Dear students, today we will talk about work done in stretching a wire. This is a very simple and short topic, and before this, you need to recapitulate, revise, recall at your own places certain basic definitions like what is stress, what is strain, what is the relation between them, what are the various types of stress, various types of strain while we apply forces to deform the bodies, right? So once you revise all that, then we can do this work done in stretching a wire. Suppose you have a wire of length L, area of cross section A, and F is the force applied due to which the wire suffers an extension, elongation by a length small l, right? Now what is the stress? We know that stress is force per unit area, so F by A. What is strain? Strain is the change in length by original length. And what is Young's modulus Y? That is stress by strain. I am doing all this on the basis of your previous knowledge that you might have obtained in class 11th and 12th. So Young's modulus, you know, is the ratio of longitudinal stress and longitudinal strain. So what is longitudinal stress? It is force per unit area. What is longitudinal strain? Change in length by original length, right? So from this expression, you can find the force. F is capital Y, capital A, small l by capital L. Now suppose dW is the work done when this force does a small extension dl in this wire. Small extension dl. So how can we write this work done? It is F dot dl, simple. And what is F? It is capital Y, capital A, small l, capital L, dl. And when we integrate the same expression, we will obtain the total work done in stretching this wire by a length small l. So integral dW is integral YA small l capital L dl. So work done, which is stored in as the potential energy in this wire, is given by YA by L square by 2, and that is half of, what is this YA small l by capital L? It is the force, and we are left with one small l only. So we can say the expression is half of force into extension. So the work done or the potential energy that is stored in stretching a wire is given by the product of force that we applied and the extension suffered by the wire, right? So we can also manipulate this expression. W will also be given by, since it is half of F into L, so let us manipulate it. We can choose to multiply and divide by A, so it is half of F by A into L into A. All we have done is that we have divided and multiplied by A. So force per unit area is stress, so it is half of stress into L by A, right? Now, if we want to find what is the work done or what is the potential energy stored per unit volume of the wire, how do we do that? We do that by, so work done per unit volume will obviously be half of, what expression did we obtain? F into L. Let me write that again. What modification did we do? That we multiplied and divided it by A. And then if we are interested in work done per unit volume, we further need to divide it by volume, and volume is the product of length and area. So length L and area A. So what are we left with? A and A go. We are left with half of F by A into L by capital L. So what is force per unit area? That is stress. What is change in length by original length? That is strain. So alternatively, you can also say that the work done or the potential energy stored in the wire is given by half of stress into strain. So this is a very simpler and short topic.